Okay, thank you, Barry. Today, uh, we're going to be looking at the general topic of education in ECE and organizing. The people who have been involved in organizing the session for New Orleans plus for today are shown on this slide, most of whom are actually here today. I know that Cindy and Kathleen will have some comments, and since Diana's here, if she wants to chime in, that'd be great too. Um, I think it's, if you just give me control of the screen, I can move to a different. Let's see if I can find the right one. What I'm going to do is go through a. I'm just going to show a fairly boring looking slide deck here because it's actually a template. So the idea of the session today and also the session in New Orleans is we'd like to hear from people who have ideas on how to get ECE curriculum move to a new level. You know, take advantage of some of the things that have happened over the last year and got 2 years actually, and treat it as an opportunity to change the nature of ECE the ECE educational experience. So we want to give people an opportunity to basically give a soapbox talk, to get on a soapbox. And so one of the things that one of the better ways of explaining what we're really about here is I'm just going to show you what the template is that I put together for this. So imagine you get 5 minutes. You know, we're academics, so we can't. I think Agnieszka is the first person I ever saw who could meet the 5-minute rule that closely. Most of us end up talking longer than that. But the idea is something around 5 minutes. Create a video where you share ideas you have for how we can basically dramatically change the ECE curriculum. We're not looking for incremental change here. We're looking for really changing the nature of the experience. And so if you put together a slide deck of like 4 slides, which is about what you need to do. I mean, you can stretch that out to 10 minutes or so. It's what I did. But the idea is, whatever ideas you have, put them on the first slide, and then here's what we'd ask you to do. And so anybody here who has an idea, please feel free to contact any one of us, and you can get a copy of this template, or you can make up your own following these very simple rules, and promote an idea that you think everybody should be thinking about as we consider what should happen with the ECE programs throughout the country. Imagine you have up to 4 slides, you get about 5 minutes. It's a good idea not to rush. Just because you only have 5 minutes, you shouldn't really talk fast, but passion, that's okay. You should record your video using whatever way you want to. The easy option is Zoom, since so many of us have experience with this. You just have to turn on the recording. You should make it provocative, make it challenging. Think outside the box, not the same old stuff. And particularly focus on opportunities that are unique to our community, unique to ECE, not to everybody else. Some themes. What are some curricular game changers? Imagine this is not a totally polite roundtable where we're actually, you might feel insulted by some of the things that people might say because people are going to get a little bit preachy. I think that's completely all right. We're looking for great leaps forward, not evolutionary change. It's time to change that. Looking not just at content, but at methodology. If you've left your comfort zone and accomplished something, encourage other people to leave their comfort zone, and avoid the not invented here syndrome, where everybody has to solve everything by themselves. Okay, so these are the basic ideas. What I'm going to do now is switch to a set of slides that I put together with some of my ideas. Then what we're going to do is I'll turn it over to Cindy and Kathleen, and they can share some of their ideas. And then we'd like to open it up to anybody with ideas that they'd like to share. Maybe you just thought of something, maybe whatever one of us says encourages you to think about something, and you end up with an idea that for a video that you'd like to create. So try it out on us today, and also feel free at the end of each time one of us finishes talking to ask questions, post questions in the chat, whatever, because we like to get a dialogue going on this, and we're going to try not to use up all the time making presentations. Okay, so let me get to my other. So this is my soapbox. And I hope you get an idea of the kind of thing that we're actually looking for here. So those of you who don't know me, I think most people do. I'm Ken Connor. I was the chair of the Electrical, Computer, and Systems Engineering Department at RPI at one time. That's how I got involved with ECE. I'm now working with the Inclusive Engineering Consortium, and I'm retired from RPI, so I'm emeritus faculty from there. The themes that I would like to have you engage in is reversing one of the common things that people like to say. I want you to think locally, but act globally. I'll say more about that in a minute. Something that's not a hard sell for people involved in ECE is engage industry. Something that shouldn't be a hard sell after the last couple of years is think about remote as a solution to educational issues, and also something that we've seen in spades in electrical and computer engineering over the last couple of years is hands-on is the way to go. And I want to emphasize that this is absolutely the time for ECE. It's the time for us to reclaim a position of leadership in engineering education. Okay, so what I mean by think locally and act globally. So ask yourself, what needs to change to improve student learning, retention, enthusiasm, and so forth? Think about what you really want to accomplish and how many things that you said, well, we don't have the resources for this and I can't do it by myself. So what solutions are not available locally? And this is the lens that the group I work with, the Inclusive Engineering Consortium, provides for problem solving. So this is something that I think about all the time. The IEC represents 20 minority serving institutions and a growing number of predominantly white institutions that are looking for ways to collaborate to solve problems rather than trying to do everything all by ourselves. So that's why I point out that this is the lens from IEC. You should be thinking about who you should partner with to find solutions. Other universities, industry, professional societies, and government. I'll give you an example of that in a second. Focus on global impact to realize local improvements. And again, this is just like thinking about the broader impact statement that you have to make for every single NSF proposal that you write. NSF doesn't care what happens at your institution. They care what the impact is going to be on the rest of the STEM community. You're not alone. And the three groups that we've seen that we really want to engage in things is industry, education, and community. There's so many opportunities when you combine forces with these other organizations. Okay, so now is the time for ECE. Just want to get that out here. Remote teaching experiences during COVID have shown us what is possible. We know hands-on learning is better. And small, mobile, inexpensive, flexible, powerful student-owned tools for quality learning are available because of ECE and should be embraced by ECE as a community. It is our students who graduated from our programs who made all these things available, and we should be taking full advantage of them. And many of us have learned to do that over the last couple of years. And seeing Sid there, I know he's a big believer in this. So I'm sure I won't get any complaints about that. ECE has the opportunity to retake a position of leadership because we can basically deliver our entire program. We can deliver it remotely if we wanted to. We can deliver it with hands-on learning, and it's not expensive. It empowers students and everything. So we have an opportunity to retake a position of leadership that people who only deal with dangerous chemicals or great big structures don't have, because how do you, a student can't take a building or a bridge home with them in their backpack, but they can sure take home almost everything you need to learn about electrical and computer engineering in their backpack. I suggest we seize the day. And a good example of a project in this direction that's part of ECE and funded by the National Science Foundation is Project Reset. And we'll have more to say about that in New Orleans. But it's an opportunity to share content that can be used educationally within ECE, and it emphasizes all these things that I mentioned here. Okay, some of the themes that I'd like to emphasize here is deliver globally, not just locally. One of the things that we only deliver, we make up courses and then we deliver them just to our students. If we delivered them to somebody else's students, we'd be able to provide courses that we couldn't otherwise provide because there's just not the bandwidth or the resources to do it. And I'll give you a couple of examples about this. I was involved in a couple of workshops recently sponsored by the Department of Energy solid state lighting effort. And they're looking at ways to educate the next generation of lighting professionals. And two examples came up. One is a guy from the Pacific Northwest Laboratories who's delivering an introduction to lighting and illumination course at Tennessee State University. He's delivering it remotely. He did it last semester. He's doing it again this semester. There's no reason why that couldn't be made available to everybody. And that means that, let's say 2 or 3 people at every single electrical and computer engineering program decide they want to take an elective in lighting. You don't have to come up with a course for 2 or 3 people. And yet, you know, if you have 2 or 3 people with 300 plus programs, you're going to have 1,000 students in a course like this with no problem. So even shooting at for a goal of 200 or something like that wouldn't be difficult. There's also a professional lighting designer who's offering a course similar to this at Morgan State University. Neither one of these are being offered in electrical and computer engineering. I want to be clear about that. They're in architecture or architectural engineering. But this is a time when lighting is moving back into electrical and computer engineering because of solid state lighting. And we need to make lighting courses like that available to students. And you can probably come up with 500 other topics you'd like to have be available to your students. Other things we can do collectively is broaden assessment methodology. I want to emphasize again that I really think this idea of don't work alone. Think of the profession, not just your course. And finally, minimize resource requirements. Make your approaches accessible to everyone. Do not make the most expensive facility on the planet and then point to it as a wonderful reason to come to your university. Do something for everybody else. So that's my soapbox. If anybody has any questions or comments at this point, I'm glad to field them. Otherwise, we can move on to Cindy. Anybody have any comments or questions? Nothing? Put your hand up.
Yeah. Ken, I have a question. Diana.
Sure.
Here. Sorry, what is the format for this? Is this going to be a rump session or what? You're inviting people to come up and show videos?
No, what we're asking people to record videos that people will be able to watch before they attend before they get to New Orleans.
Okay.
And then we'll have discussions in New Orleans. We only have an hour in New Orleans, so it's not enough time to present lots of information.
Right.
Ollie, it's good to see you. I see you have your hand up.
Yeah, great to see you again, Ken, as well as all my friends at ECE. It's wonderful to see you. So I look at your map here and I see deliver globally, and I see a map of the US. I'd like to broaden that to really globally looking worldwide, and just wanted to make that comment.
That's an excellent comment, and it's one of the things that's been happening with, I've given workshops as part of research programs over the last year, and normally I would fly to some place, give that workshop. I'm doing it remotely now, so they just open it up to the world, And so I did a workshop at Morgan State, and I think most of the attendees were from Nigeria, literally in Nigeria, watching it from there. And I think we had 40 different countries involved in the workshop that normally would have had people from within a few blocks. That was it. But
Yeah.
it's important because there's many interesting ideas everywhere. And if you can collaborate with people from different places, I think that's great.
Anybody? I think having these low cost devices and so on that allows more inclusivity worldwide in basic prototyping and so on is a great opportunity. So I just wanted to make that comment. Thank you.
No, that was great. Okay, I'll turn it over to Cindy, who I think has strong opinions only on everything, right? So.
I love the invitation to have some strong opinions. I just am trying to make my PowerPoint. Just a second, let me pull up my PowerPoint. Hang on. As soon as I'm on Zoom, it makes my desktop go so slowly. I was going to try, okay, I'm not going to. I was going to try to put myself into the PowerPoint. In case you don't know, Zoom currently has a thing that when you share your screen, there's an advanced option to put your PowerPoint behind you, but I'll cease and desist with that so I can be faster. Oops. Get back up where it belongs. Okay, so Ken was absolutely right. I'm Cindy First. I'm a professor of electrical and computer engineering at the University of Utah, and I do have some strong opinions about engineering education. They actually started when I was a student. I dropped out of engineering 5 times because I didn't look like the other engineers. It didn't completely fit me. I had some life challenges, and I came back in each of the 5 times because I'm fascinated with electrical engineering. I have to say that there are other students like me too that we have lost from our profession that I am sorry that we have lost and that I hope will return. So I'm going to talk about after COVID. And I know we're not quite after COVID, but we're after the COVID experience. I'm going to talk about flipping and flexing. And I'm going to say they are no longer optional. And really when I'm on my soapbox, I'm going to say it's unethical to teach any other way. So before COVID, we often had a classroom and the students went home and did their homework. Typically, we tried to get them problem solving together, but during COVID, their classroom became a Zoom room and most of them were working alone. We actually can do much better than that now, and the flipped class has in fact become the norm. I've been flipping my class since 2007, and it has made such a huge difference in my experience and the students' experience that I am willing to say at this point that it's unethical not to. When you are not flipping your class, you lecture in class, you spend all of your time talking to the students, they sit there and take notes, and then they go home and try to do their homework. It looks like it's written in Greek. In fact, I'm in electromagnetics. Most of my homework is written in Greek. When you flip your class, you send the students home to watch pre-recorded video lectures. That's what they do. Lectures only maybe 20 minutes long. They do that at home. When they come to class, it's very active. We are actively engaged. We are talking, we are working problems together, we're challenging each other. So the class time becomes a much more engaged thing than it ever was before. It is, I believe, my optimal time with my students. Well, as I said, I've been flipping my class since 2007 before it had a name. I've taught a Teach Flip workshop all over the world, as Ken's mentioned, and I've done this post-COVID as well. So when COVID happened, I don't know how many workshops I did around the world to help people get started with recording video lectures so that they could continue with their program. So flipping the class has actually worked out brilliantly. In my case, I took a sabbatical in 2008. That's why you don't see 2008, but I'm a good teacher. I was a good teacher before, but turns out as soon as I flipped my class, that's all it did. It made a huge difference. The students loved it. My teaching evaluations soared. All right, teaching evaluations are great. And this is in introductory electromagnetics, but did the students actually learn more? And I am going to say the studies today tell us it depends. It depends on if you use really great pedagogy before and after. So here are some of the things that are really known as being excellent pedagogy in the world today, research-based. My focus was on active and engaged learning and being able to bring in the other aspects as well. And I needed more time. So the flip class actually bought me time to use my entire classroom for an engaged and active learning environment. Well, here's what happened. Many of us had flipped before. About 50% of our electrical engineering classes were flipped, meaning there were recorded lectures so that we could optimize our in-class time with active learning. But during COVID, in our department, more than 90% of the classes flipped. Oh, this was a lot of work for faculty, but our department made a very strategic decision. So I'm going to say, after COVID, now what? What if someone coughs in your class today? It's unacceptable to come to school sick. It is barbaric, and I'm going to stand on this soapbox and say unethical and barbaric that we ever made students come to class sick. If you get sick, you're probably sick for 5 to 10 days, right? Just with a normal little sniffles cold. And that means that you would have missed 2 weeks of electrical engineering. How many electrical engineering classes could you pass if you had to stay home for 2 weeks? None of them, not a single one of them. So we have been forcing our students to come to school sick. How many of you have ever given a lecture when you were sick? Oh yeah, I've had a fever of 102. I have been unable to speak. Come to the front of the class so that you can hear me because I can't talk today. That is barbaric and unethical, and we can't do it anymore. So the elephant in the room is we can't go back to the good old days because they weren't good old days. In fact, what if somebody coughs, or what if their kids are home from school? Or what if they have a baby? I had babies in graduate school. I was trying to get through graduate school with these tiny children, walking back and forth in the back of the class with a baby in a tummy pack while another student took notes. This is ridiculous. What if your car breaks down? That's happened to all of us. What if you just don't feel well? What if there's a blizzard? That was last week, right? Or what if you can't get off work? What if your professor's sick or traveling? We need options. We needed options before. We need options now. They are not optional. They are not options. They are necessary. So if you have an in-person classroom, which is awesome, it really is. The students learn great, we teach really well. But even when you have an in-person classroom, you simply must have an online Zoom option as well. Now that could be synchronous or asynchronous. They tend to work better if they are synchronous, but then recorded for later. It's called hybrid flexible or a high flex classroom. These are actually well studied in the educational literature. We just haven't been doing them, but we are now. So our department actually made a strategic decision that this is where we in electrical engineering want to be. We want to offer our classes in person, but we want them in person plus. We want them to have an online synchronous Zoom option, as well as recording that for students who need to see it later. Here's an example of my professor, Angela Rasmussen, who's teaching in this classroom. So what you do, there aren't special classrooms. No, there's no special equipment, just a tablet and just our regular classroom. So it was a little bit challenging at first. I've been teaching this way. I felt like a total rookie. And I will tell you, I'm an experienced educator. I felt like a rookie, but oh dang, was it good for me. So students loved it. I've loved it. 80% of my students came at least once to the Zoom classroom for the reasons that I listed on the elephant slide, because life happened and they needed that support. So it is no longer an option that's optional. It's now an option that's necessary. So on my soapbox, I'm going to say, after COVID, flipping your class, having recorded lectures so that students are able to watch them later, flexing it so that students can join both in person and online as needed. These are no longer optional anymore. These are options that are essential, and education is the better for it. So as Ken mentioned, teaching workshops all over the country and the world. There is a resource page here if you would like, teach-highflex.utah.edu. And I hope that you'll join me there and learn a little bit more about high flex teaching. Make a commitment in your department that this is how you're going to function. Thanks very much.
Thanks, Cindy. Anybody have any immediate questions or comments before we move on to Kathleen?
That was great. I was really impacted by your presentation there, Cindy. Thank you very much.
Thank you.
We're starting that, but we haven't been able to implement it department-wide. So hopefully I'll have the chance to speak to you about that.
I would love to help. Let's change electrical engineering education delivery.
Cindy,
Okay.
I just wanted to say that was awesome to hear. That was very bold. And I'm going to take that up, that we should provide this flexibility forever. Never thought about it, but thanks.
Thank you. I'm going to record, I didn't get it recorded last night. I'm going to record this and put it on the teach-highflex.utah.edu website. And I hope that you will let me challenge your faculty.
Okay, thanks, Cindy. Kathleen? Unmute.
Okay,
There
yep,
you go.
I will. Sorry. It's the usual thing that everybody has to say when you're on Zoom. So I only did one slide. Sorry, I did not have the time to do the great presentation that Cindy did. So I have 3 points that I would like to talk about. The first one is sort of a corollary to something that Ken mentioned about thinking locally, acting globally. Is my impression is engineering, electrical engineering specifically, has become too broad. Our high school students have no clue what this discipline is. It's not really taught very or mentioned very well in high school anyway. But trying to explain to a student what encompasses electrical engineering means that we're doing something that's this broad. And yet when they come into the discipline, they're of course given the foundation materials. And then we say, oh, well, you got to sample power, but they weren't interested in power. They wanted to do communications, but they only get one course in that. It's too broad. It's not attracting students. We've all seen this. We need to split and make this discipline more focused so that students know what they're getting a degree for. They can go after it. They can move between degrees. That would be great. But the other thing is, I don't think we're training our students properly for the jobs that they're getting. Most students are now doing also more systems integration than design, yet we're still emphasizing hardcore basic design in our degree programs. And then you look at who's getting the design jobs, and they're people with master's degrees, and we're not giving enough encouragement to our students to go after that master's degree. So I think we should also, while we're making, I'll say, a autonomous systems engineering degree program and a communications degree program and some other, power engineering, look at creating a direct to master's degree program so that it's clear that students who want to do some more hardcore, if you will, design know what direction that they should be going in. Again, it should have paths into from these other degree programs and paths out if they decide they don't want to do it. But we're not doing our students any good service by saying, oh, and you can become an engineer after 4 years, when clearly the only people that, and I know it's a generalization, but the only people that employers want as design engineers are people that have graduate degrees. Architecture has for decades now had a 5-year program where it's clear that you need to go through that 5 years in order to become someone that could actually design something more than just a, shopping mall box. So that's my first suggestion, is to do that. So, so my second suggestion, and this may seem a little counter to what I was just saying, but not really, is that we all agree that having a research experience is important for education, right? It's what got me into my PhD program. I'm sure other people have had similar things, yet research funding is not available to engage all of our undergraduate students in these activities. Yes, NSF focuses things on REUs, but they're really sporadic. They don't touch all students and they don't touch all institutions. I think we should be distributing more of our research funding down to the undergraduate students, down to the undergraduate programs, so that our students can have these experiences and be more rounded engineers, more able to focus their interests on what they want to do. And if this does become incorporated into the curriculum, then it can be added as a criteria if we wanted to. And lastly, there seems to be this really big push by R1 institutions to grow their undergraduate populations. We're seeing it where I am, which since I didn't introduce myself, hi, Kathleen Meehan, California State University, Chico. We're seeing it in California. I know one of my previous institutions is also doing a bang up job growing their undergraduate population. But these places are teaching classes of, 150 to 200 students, and it's not ideal for our undergraduate students. We should be growing, if you will, the schools that can manage to interact mostly one-on-one. I know every student that's in my classes. I'm not sure that I actually managed to do that at R1s too, but really memorizing 150 names was something that took most of the semester. But, if we want to retain students in our programs, we need to make personal connections with them. And it's extremely difficult in R1 institutions with humongous classes where some of the classes are being taught not by faculty, but by our graduate students to make the connections that we need in order to keep the students in the program and make sure that they have all the opportunities that they should have, be able to direct them to different research opportunities, to different internships, courses that they should be taking, graduate schools. You can't do that when you've got 150 or more students in your class. So that's why I think, R1s should focus on what they're really good on, which is the graduate research, and we should make sure that the other institutions are well supported so that we can keep students in the programs. Thank you.
Okay, thank you, Kathleen. Any immediate comments? Because what I would, oh, Assad, you have your hand up?
Yeah, I was, Catherine, when you started talking about systems, I was hoping that you also talk about that we need to have a little bit more of a system engineering design into our curriculum. And this is the area that I feel that we have lost it to other programs, especially mechanical, that they basically think they own the design process. And that's something I think we need to do that in order to also be able to actively incorporate entrepreneurships, which is another area that I think it's we could benefit from. Thanks.
I agree. I will say there's, if you will, there's a lot more jobs for systems integrators than there are for people that create new transistors or whatever. And the other thing I see is manufacturing engineering doesn't seem to understand that electronics get manufactured. And I think it's hurting our discipline quite a bit. Ali, I see your hand is up.
Yes, Kathleen, I wanted to thank you for the wonderful viewpoints, and I think they are very, very good. I just take a point with your first idea of thinking that the ECE is, or electrical engineering is a bit broader and should be broken down into multiple majors. A few years back, I know ECE has been looking into why ECE is not growing as fast as, for example, mechanical engineering. And one of the reasons there was that the mechanical engineering is perceived to be a more general major, and that attracts students more because students see a multifaceted directions in the mechanical engineering. If that is the case, are we not walking against the tide there? And I think we had a study done, and that came out of that study.
I guess I disagree.
I assume,
Most
yeah,
of the high
question.
school students that I talk to, when you talk to them about mechanical engineering, they're thinking robotics, and they're not thinking of some of the other areas. I mean, I don't hear anybody coming in or about saying, oh, I want to do fluid mechanics or combustion, right? I mean, it's robotics or autonomous cars or something along that lines. When I talk to high school students about who's coming into electrical engineering, I'm getting, oh, my parents suggested that I go into this, not, I really want to do this, you know, or, I mean, the only people that seem to really know what they want to do are maybe the people that are interested in power, but the other people really don't seem to understand why they're gravitating into the program. Diana?
Yeah. Hi, Kathy. You put a lot out there to talk about. And this issue, I'm not sure if it's much about curriculum as it is. Well, in my mind, it's not, but it's more about marketing ourselves. I don't know if other people would be interested, but maybe I could share this at our conference. We just opened a threaded curriculum. I just joined UT Arlington last year, and we started with we knew we had to educate. Okay, so step back. At UT Arlington, our primary audience, our customer, are students here in the DFW area that want to stay in the DFW area and get good jobs. So we have a very tight strategic industrial group. I worked with them to define kind of the 5 areas that people hire in our local, in the DFW area. And so from that, we were able to select down to 5 tracks. We call them tracks: energy, power, photonics, embedded circuits and systems, controls and machine learning, and then standard signal processing, blah, blah, blah. And so we introduced a threaded curriculum. And so now students can go to the website, see these 5 areas and types of jobs that you can get. And then we've kind of threaded the curriculum so they can string like little beads of the courses through our curriculum, so they pop out being able to work for Encore with a power electronics track specialty, or whatever. So we've called that a threaded curriculum.
Okay.
Does that resonate with what you're talking about?
I think it does, but I'm again thinking, in some ways, what I'm seeing is the deep learning, artificial intelligence, people are moving away from wanting to know how electronics works and things like that. So I'm seeing things that look really like computer engineering becoming a major from that standpoint.
Yeah, it is a major at UT Arlington, and it's under computer science, so it's not in my purvey anyway.
Yeah,
but we embrace what we do well, and that's what we specialize in.
Okay, I'll just bring up, and some of you may know that I used to work at Virginia Tech, and I still monitor what they're doing over there. And I'll just bring up one of their web pages, if you don't mind. This is what they've done. And I'm just saying, in some ways, I see this as outgrowths eventually, if possible, new degree programs. But they've now got a whole host of different tracks, right? That they're offering to students, where you can get, if you will, a concentration in photonics or whatever. But look at all of these. So, I mean, this is a huge field now. So, and it's really hard to sell huge fields to students coming in. It's much easier to say, oh, well, if you come here, you could be, a systems control engineer, and this is what they do. Or you can come here and become a unmanned vehicle or unmanned systems person, engineer. Electrical engineering doesn't resonate with students anymore. I mean, the state of Virginia, when I was there were 3 high schools in the whole state that taught an electronics course at the high school level. It's just not talked about there, and we need to have something more catchy to draw students in and make them committed to the degree program.
Yeah, in this area, I think one of the things that I think the community has struggled with is, somebody says, what is an electrical engineer? What is a computer engineer? It's a difficult thing to define, And so because it is so broad and there's so many different aspects to it, it is, I would say that, you know, my PhD is actually in electrophysics, because that's what was then Brooklyn Poly did in terms of separating out the research areas. And I think, you know, electromagnetics and solid state and areas that are very hardware oriented and circuit design and so forth, they're very different than what has traditionally been in communication and controls and that sort of thing. But we are in the same department and we have shared courses together. And I do feel like I have much more in common with people in my department than I do with people in mechanical engineering or chemical engineering. So I think it's possible to do both of these things, but I think one of the problems with defining what an electrical engineer is that they are so different. There are so many different things that we do. So I think that I do like this idea, and maybe Cindy, you might comment briefly on what you're doing in Utah with regards to this, because of the requirement changes for the EE degree and so forth.
Yeah, we actually also are doing a series of tracks that cross, in many cases, our subdisciplines, such as wireless crosses electromagnetics and signal processing. No high school student is going to understand what electromagnetics is or signal processing, but they can understand that wireless communication may be interesting, you know, with 5G and the airplanes and all of that stuff. So bringing it to a context, meeting people where they are and what they know about is clearly key. And so we've been trying to design our tracks to show them how they get there, because of course they do. That's where the jobs are. So I'm totally resonant that tracks are an important thing. I just put a note in chat, however. When was the last time that ECE or someone else did a market survey of our incoming students to find out what they want? So I did a talk last week to a group of incoming freshmen, and I'm recruiting for electrical engineering compared to other engineering. So they're coming into the college, but the question is where. And when I asked afterwards how many students are interested in electrical engineering, about 75% of the hands went up. Okay, that's because I'm there. But when we asked them, put in chat why, the vast majority of those was because I had shown them a bunch of hands-on things they were going to do as freshmen, sophomores, juniors, seniors. So I just did an informal market survey to be like, oh, wow, I can talk about this. And if that's what's, you know, generating interest, I think, you know, okay, I'm an old guy and I need to know what my students are thinking and wanting. And I want to give them what they want because I can. So I think we should do as a group an overall view and find out what students are wanting, and then kind of provide a template to each department saying, you know, students want to know about your hands-on experiences. So on your webpage, talk about, here are my hands-on experiences for this, you know, this university versus, you know, another university. They want to know, will my job have impact? Okay, well, talk about some of the impact your alumni are having. So I'm thinking we can do a whole lot better job than we have if we did it collectively. And the tracks, absolutely essential. So it's definitely a 2021 thing.
Yeah, I think that, I mean, I think you just made an excellent case for something that I've been arguing for a while, and that is that we do need, as a community, to create outreach content, and it has to be focused on hands-on. It can't be anything else. And I believe standing up there and showing pictures of this kind of thing, you could make a cell phone, you could do this, you could do that. No, you don't want to talk to them. You want to give them things to do and say, okay, now here are the things that are involved in electrical and computer engineering that are in that product that you just built, or that little experiment that you just did. And it is, and I tell you, and you know this, this is so much fun. I'm not sure why everybody isn't doing it all the time, because outreach with hands-on activities is probably the most energizing thing you can do in a day.
Ken, in your slide, you said something about thinking locally, acting globally, but I'm going to ratchet that back again. I think thinking locally and acting locally has a lot to do with where we are right now. Again, I've spent a lot of time trying to learn who my students are, who their employers are. And so we hold monthly tours. We've got it down pat, with the hands-on stuff. We invite all the schools from around the DFW area to come see what EEs do. And so we give them things hands-on, we give them things to do. We show them through our research labs, and it's kind of a canned experience now. We know how to do it. But, we spend a lot of time studying who our clientele is. So I would say, think locally, act locally.
Yeah, it was just, I was only saying that the think globally and act locally is just the phrase that people use. I just wanted people to think about it a different way. And you're absolutely right. You need to know people hate this in the academy, but you need to know your customers. And it's at the beginning of the pathway and at the end of the pathway. We need to be talking to the industry.
Yeah, because
what you've done is you've connected from the beginning to the end. You've shown the students where they can go, and you're using all that information to inform the process you're creating for them to go through. That's a great approach.
Yeah, I agree with you. Anyway, thanks.
Yeah.
Thanks.
I'll mention something.
Really nice section.
Sorry, Diana. Sorry for talking on top of you. I'll mention something that we're doing starting next semester is we finally got 2 electrical and computer engineering courses into our general education track. So we're going to have a wearable electronics class for our general population next semester, and the following semester, because we've already had something like this going, it's going to be a audio engineering course because it's part of our recording arts program, and we're just going to open that for the general population. So we're going to be starting to do that. It's got a 2-hour activity, so we've got hands-on in there, and the only requirement is that students have taken a math course at the university. So we have to be prepared to have students that are in trig going into these courses. So it's going to be, I'll say, a light touch from a mathematics standpoint, but it's going to be something that, we could export to a high school summer program type of thing. So that's what we're developing here. And part of my reasoning is that if I can grab them in their freshman, sophomore year, which is when most of our students will be taking this, possibly some of those students will transfer into engineering. So.
Ken, I hate to interrupt, but I've been watching the chat and I see a couple of comments that are probably worth following up. One from Sid and another from Tony Maciejewski. But Sid says you have some data, some feedback from students on what they think that electrical engineers do. Can you share a little bit of that?
So yeah, thanks Barry, for a fantastic conversation going here. So I teach a summer program in which we introduce all engineering to high school students. They're rising seniors. The program is actually called Management and Technology Summer Institute. Students interested in a dual degree program at Penn. I focus on engineering. And so I ask these generic questions, it's a Google form, and I would say, what do X engineers do? What do bioengineers do? What do chemical engineers do? And so there is also a question, what do electrical or computer engineers do? And most of them have answered. And I'll go back and actually prepare this in a spreadsheet. It'll be a nice thing to read. But I recollect, they think we'll sit in a lab and build and troubleshoot circuits. Some of them even mentioned we repair things around. So for an incoming high schooler, the projected image of electrical engineering is very electronics, very circuits. So perhaps some said we build computers, but they completely missed out on all the innovation that is out there. Nobody said we build products that control everything that is around us. Nobody felt that we are the innovators. All of that was in the software. So in the computer science part is where you see all innovation, where you see all robotics, where you see all big tech, and where you see all the buzzwords. But the electrical engineering felt completely out of that market glamour. But anyway, I just wanted to chime in. Great conversation.
Yeah, I would add an important thing, and I know it's been part of discussions I've had with Kathleen and Cindy in the past and others, is that we have this opportunity as electrical and computer engineers is to remember all the letters in our name. and that when we're working on a problem, it's a combination of hardware, software, digital, analog. I mean, all of these things get combined, and that brings up this system approach to doing things. And the idea that you can create something with varying degrees of software and hardware in it. I mean, this is the direction that industry is going too, because even companies that you would say are pure circuit design companies like Analog Devices are hiring in the software area now, because you have to be able to do things in software and hardware. It's always been the case, but it's even more so the case than it's been in the past. And I think and again, all of our stuff can be fit in a little box that goes in your backpack. And so students can be given a really robust systems design experience, a systems learning experience by combining software and hardware and firmware and everything else that gets involved in building a system. And it is exactly what people have been doing forever. I remember one of my favorite examples in this area was talking to a guy who worked for a Bell Labs spinoff, and in the height of the .com boom, that he was, they were building new communication systems, and the primary profitability trade-off was between the yield of the lasers and the number of lines of DSP code they had to write. So you have junk lasers, you had to write more code, or vice versa. And so in the end, they knew this from the beginning, that this is the way they were going to have to, they would have to go about designing this system. The system was not just software, not just hardware, not just a light source, not just detectors. It was everything all at once. And there's a point where you decide it's going to have this much of this in it and this much of that in it. And again, being able to argue this with students and show them, look at their cell phone. There's almost every aspect of electrical and computer engineering in their smartphone. And it's not a hard thing to use that to explain to people, and then do a little hands-on experiments so they understand how each little bit works. Kids love it. I love doing it with them. Other people I talk to who have tried to do it with them love it too. It's just great fun.
But I think, Ken, that argues for distributing design throughout the curriculum. And I'll say making use of speakers and LEDs and other things. So it's not, oh, we're going to do another voltage divider. Oh, look, it's a voltage. There's got to be something that really ties it into the students. I mean, I didn't understand how valuable that was until I had, I'll say, an A minus student help me develop a lab, oh God, about more than 10 years ago. And he said, and it was an op amp lab, and I asked him to throw a speaker on there. And he comes back and he says, I didn't really understand gain until you made me put that speaker on there, and I heard the difference. And so, and that's an A minus student who could calculate the gains all he wanted to, but he didn't see the application. And once you see the application, you see something, you hear something, you understand it better, and you can see then where else you might use it.
Yeah.
Well,
So
can I-
is it, Barry, you have another comment from the...
A comment from the gallery. No, I see. I mentioned that Tony had added something in the chat about the Tailfin survey, or the Tailfin consulting. Tailfin is a marketing firm, and we had them do some work for ECE on branding and marketing. Tony has now directed a question to me. Do I know if the Tailfin data is available? I have to answer, Tony. I don't know that. I will have to follow up on that unless one of my colleagues here can answer that directly. That was right around the time I was sort of rejoining ECE, so I can't say for sure. But no, certainly that's something we should follow up with, because I do hear a lot of how do we market ourselves better in this conversation, and it sounds like a conversation that we've been having for quite some time. So there's maybe we should be revisiting some of the things that we looked at earlier. Sorry, Ken, go ahead.
Okay. No, that's it was a good question. And one of the things, just to say a little bit more about the session, one of the things that we are about to do is to encourage people like Tony and the people at Virginia Tech that he mentioned who have had RED funding. Everybody who has done something very different to revitalize their departments has seen ideas that they would really like to see everybody else consider, and are things that are not standard operating procedure. So I think we're looking to them to share from their experiences something that is really, that would really force people out of their comfort zone, but is going to have the potential to dramatically change the experiences of students. Does anybody, I mean, I'm hoping that some of you have been stimulated to think of other ideas or remember that there's something that you have been thinking about. Does anybody want to try an idea out at this point? If I'd like to see what suggestions that there are. Yeah, I'm not seeing 1,000 hands going up. So. Assad.
Yeah, I mean, since you asked, I'm going to just throw out a wild suggestion. What I'm saying is, I know the future is based on, let me just start with this background. Before, during the COVID, our enrollment went down. So the notion was that because we are online and Zoom and things like this, so if you come face to face, enrollment is going to go up. And now we started the last semester, we started face to face, and enrollment did not go up as much as we expect. And there's still a lot of the students actually asked for, can they join via Zoom or some other online visits? So I'm thinking that this future is no longer face to face. Future is, I think Sydney was pointing out, is basically a hybrid is the future. So you want to call it flipped classroom or something else, but it's not a face to face alone. And in that area, there are two technologies or three technologies which are working next to each other. One is this virtual reality and augmented reality, and also what companies such as Google and like that and Facebook are doing, which is basically are working on putting billions of dollars in that meta environment, whatever they want to call it. So that virtual type of reality, in my opinion, becomes more and more one of the way the students may like it, which brings us to what I see the future is anytime, anywhere approach, that you can take your courses anytime you want it at anywhere you are. It doesn't matter if what state or what country you're in. So this is I think that was wide enough, right?
Indeed, but it's again what you're commenting on here is the technology associated with educational delivery is changing, and the expectations of students are changing, and as Cindy has said, we have a situation where students need to continue having the freedom to be physically there or not physically there for all the reasons that she mentioned. But the things that you mentioned is if somebody is in the military somewhere in the world and on an odd schedule, I remember when at RPI we had a nuclear engineering program for the nuclear Navy people, And they had this really odd schedule that changed every single day. So you actually had to have courses that rotated throughout the day in order to give them their master's degrees in nuclear engineering. And why? What you need is anytime, anywhere education. And but it means that you put your resources in a different place. You don't put them for people standing somewhere during this particular hour and going blah, blah, blah throughout the class. You've got to do something really different. And again, I'm going to just keep saying this over and over, that we are in a discipline that does not require us to have great big stuff to do what we do. And so every single student should have the same hands-on experience, because they can get a box of stuff and do things. So Cindy, your turn.
So I did actually start my first flipping experiment because of a deployment mid-semester, and that student got through great, but that was where I was sending CDs overseas, but it worked really well. But I think the biggest challenge to this is actually our humbleness. We've been used to the concept that we can measure our quality by the number of students that show up in the seats of the chair of the classroom. And that is a false model. And we need to humble ourselves to say, whether the student is there, whether they're Zooming in, or whether they watch the Zoom later, my job is to teach them and impact them. And we should be judging ourselves by the students that we teach, by the students that we keep, and by the students that we impact, never mind the seats in that classroom. And when I talk to faculty, and in fact, chairs and others, a lot of that is really an attitude shift of us more than it is an attitude shift of the students. We need to not judge our students because they didn't show up in that seat in the classroom. Please remember me with my 2 little babies, and imagine every time they had an ear infection, all of that, I'm struggling just to get through class. Please don't judge me because my children have ear infections today and I can't come to class. That is a humbling thing that we need to change about our academic profession. And that's what I'm going to soapbox. We need to humble ourselves.
The other, there's another thing that comes up in this, and like other people, I spent some time studying the impact of COVID on students, because the Inclusive Engineering Consortium has all these minority serving institutions in it they're particularly vulnerable to not having access to facilities on campus and so forth, that they may have bad Wi-Fi at home or none. They may have poor just digital tools to work with because they don't have the money to buy things that are the same as what somebody going to from a richer community. And so it's essential that we also figure out how to make sure that everybody has equal access to learning, which means we have to listen to people, and that's what running this flexible operation does. But you can't just do it. It's very easy to do some of these things and focus on, the 10 students that you hear from most easily, or the fact that it turns out, as it does, that it also gives the faculty member flexibility that they didn't have previously. I mean, the whole idea that you can actually you can be at a conference somewhere and still be running your class. And that was not something you could previously do. And so we have to remember not to just think of ourselves, even though thinking of ourselves is actually a plus in this regard, that the idea of having this level of flexibility to be able to do things that we can do things anywhere, anytime is also a plus. But we have to do exactly what you said, Cindy, and that is we have to focus on how much learning is going on and who is really learning and getting something out of the course because we've chosen to deliver it in a different way. I found we tried a lot of different experiments through the years, and we get pushback from students, not just colleagues, because they're used to doing certain things. They maybe spent most of the first 12 years, 13 years of their education hiding from people as much as they could. And now we're telling them, well, sorry, you don't get to hide here anymore because we're just going to be there for you all the time and be responsive. And so we expect you to be responsive to us too. And so there's a lot that has to be addressed in terms of making this work, but it's work, it's fun work, it's worth doing. I think we're just about at the end of our allotted time. Anybody have any other? This is your last chance to make your statements. I do love the idea of looking at international, because it's again, there's no reason why we have the good fortune to be English speaking, so that this is the language that people have managed to learn throughout the world, and so it's possible to interact with people almost everywhere, as long as you remember that what people think of as English in other countries is not the same as down the street from where you grew up. But we're pretty used to that from our experiences teaching people from all over the world. Any additional comments? If not, I think we'll turn it back.
Okay, it looks like we have everyone back together. Thank you again for your participation in today's program. We really appreciate it. Thank you to Keysight and IET for hosting the corporate suites. And of course, thank you again, Ken, for a great discussion and with your panelists in today's program. We're looking forward to another fantastic day tomorrow. We have a session tomorrow on future ideas for hands-on education. Sid Deliwala is going to lead that discussion, and another one we're absolutely looking forward to. We start tomorrow at 10 a.m. and look forward to seeing you all then. Thank you again. Have a great day.